Hello and welcome. My name is Vishwanath M. In this video, let us try to learn and understand the concept of doubly linked lists or double linked lists. If you are referring the VTU syllabus, this is program number 8 of Data Structures Laboratory. Before we jump on to the video and understand the concept and the program, I would first like to mention that the structure of the 8th program, that is what we are going to study in this video, program number 8, is exactly the same as program number 7. So efforts have been put to make sure that both the program looks exactly similar, except of course the conceptual difference between single linked list and double linked list. So I encourage the readers to study 7 and 8 together and correlate the concepts between 7 and 8, so that learning both the programs will be much more effective and easy. So having said that, let us now jump on to the 8th program. You already are familiar with this image. I had used an image of another train for the explanation of singly linked list. In the doubly linked list, or we already know what linked list means and what single and double indicates. So in a single linked list, there used to be only one reference or one link or one pointer, and hence the name single. And here in doubly linked list, there are two references or two pointers, hence we have named them L link and R link appropriately. So this is the structure of a node in a doubly linked list. Again, why this image makes sense and is relevant in this program or video is because you see in the train image here, each compartment has two links, one at the left, one at the right. So this bottom image of a train is actually very meaningful and easy to conceptualize and visualize the concept of doubly linked lists. So there are links at both left and right end, as you would see in the image. So if you have followed my 7th program video where I have explained the concepts, I have retained the same pattern, so that again learning 7th and 8th becomes comparable and easy. Alright, so now we have the background of what doubly linked list means. So let us now very quickly get into the program and learn the concepts parallelly. So we have two header files in the program. We know IO for input output and stdlib for dynamic memory allocation function. We have to create a structure for this doubly linked list, because in the program question the requirement is to create a node which represents a employee database. So for an employee database, the fields are already given to us: SSN, name, department, designation. All of them are character arrays. Again, I've kept the same convention as what we used in P7 or singly linked list. So learning the program is actually very simple. And another extra field here is designation, and of course the salary of the employee, and long int phone number. We are already seen this in program number 7 as well. Now the key difference in single linked list and double linked list is with respect to the link itself. In single linked list, there is to be only one link, so we just had one pointer here, whereas in doubly linked list we need two pointers, and hence we have created two links: struct node star L link, struct node star R link. So these are the two pointers. I hope I have made the concept of node and structures already understandable by now. You could consider struct node as a user defined data type, and each node in doubly linked list has three components: the data component, left link and right link. So there are three components of structure node, and here in the user defined data type we are creating a user defined data type to save an employee details. We know why we use type def struct node star node. So type def is like creating a nickname. Instead of naming struct node star, we could simply use the word node, which will imply and mean the same as struct node star. Initially we create a start node, or you could even call this a head node, but as we have followed the same convention, let us follow the same in this video as well. So node start, or initially we create this start node as null, and we use count as a global variable to indicate the number of nodes in the doubly linked list. Alright, so let us now get into the first function, node create. We know that create function is used to create independent node, or when I say independent, it is unlinked node. So what I mean by that is you are like a manufacturing a compartment but not linking it to any other node. So this is a independent node. How do we create a node in DLL? You will understand in this function. We will create node s node, a variable to create the independent node, and we use the malloc function, which is dynamic memory allocation function, and we are already familiar with this syntax of malloc. Malloc returns the amount of space or memory defined by the size of struct node, and the return type of malloc is void, but we are typecasting it to node star, struct node star. Hence we are using this node within parenthesis. So you must understand conceptually S node is a pointer to a set of space or to a memory location which will store the struct node. If S node is equals to null, that means if the pointer is pointing is a null pointer, that means memory is not available. Anyway, this would not occur normally. If that is occurring, that means you have probably run out of memory. Since we are dealing with employee details, we print the message, enter SSN, name, department, designation, phone number of the employee, and we input all the details using scanf function. So if you are comparing 7th and 8th program, all of this is very similar, except of course here we are replacing USN by SSN, and we are adding another character array called designation here, and there we didn't have salary because students wouldn't have salary, whereas employees would have salary, and S node of phone is retained. So as I already explained that in a doubly linked list, each node will have two links, L link and R link, and initially both the links will be null because we are creating independent nodes. And as soon as we create a node, we have to increment the count value, and we return the pointer S node what we just created. So we have understood create function. Moving ahead, we know that in both the, so you could have this image for visualization somewhere here, and let us move on with the program. Insert front. So we know that in these type of programs we are expected or asked to demonstrate insert functions and rear functions, insert functions and delete functions at both ends. This is the front end and this is the rear end. So in this program we are calling the front as front and last or rear as end, and I hope readers are already familiar with this naming convention. In insert front, so let us very quickly understand the concept. So we create a temporary node, and assuming that this was the existing doubly linked list, suppose we had two compartments, what you are supposed to do is first manufacture the temporary node or manufacture the compartment. Then there are two links that we have to configure right now. We have to configure the right link of the first node or the temporary node, and we have to configure the left link of the existing start node. Suppose there are only two compartments, the left link has to be connected to the new compartment, the right link of the new compartment has to be connected to the existing start node. I hope that is very easy to understand, and especially with this train image, understanding becomes more visualized and effective. So having understood what the concept behind insert front, let us now see that the same is happening in the code here. We are creating a temporary node, and you see that here if the start is null, that means we don't have an existing DLL. That means suppose we didn't have a train at all, the first compartment will be the start compartment or will be the head compartment. So that is what it means. If start is equals to null, return temp. But if this is not the case, what does insert front means? We have to insert to the front. That means as I said, the right link. So I urge the readers to understand the program, not memorize it, because efforts have been put to make the understanding achievable or possible. So as I already said, for the temporary node you have to configure the right link to the start. So temporary of right link will be pointing to the start of the left link. So this is the left link, start of left link will be pointing to temp. So I hope the understanding of insert front function is now clear. After of course configuring the links, we return temp as a return type, as a return value. After insert front, let us now jump to delete front. In delete front, we know that already the starting compartment or the starting node has to be deleted. So again, in case of a singly linked list, we just had one link to deal with. If we just make the link as null and free the space, we would have deleted the node in SLL, whereas in DLL we have two links to deal with. So the right link of the start node and the left link of the second node has to be made as null, and we have to free the first compartment or free the first node. So let us see the same in the code here. Node delete front, node temp. If start is equals to null, that means we don't have a linked list. We just type linked list is empty and return null. If start of r link is equals to null, so we had the same in SLL as well. If there was only one node in the linked list, so we just have to delete the node and return null. But if we had more than one node, we have to make sure that we are configuring the second node as the start and delete the first node. So what this means, if start of r link, so when does the start of r link be null? When there is only one node and there are no nodes further in the linked list. If start of r link is equals to null, printf employee node with SSN, whatever is SSN, we are printing that is deleted, and we decrement the count, we free the start pointer and return null. This is the case when there is only one node present in the DLL. But if that is not the case, we know what to do. We name the start node as temp, so temp is equals to start. And what we are doing next, we are this is a kind of increment. So we have already understood what this means. Start of link is made as the start node. So this was the start node earlier. After deleting this, the second node will be made as start. So students could take a screenshot of this image and refer it for both the theory as well as laboratory purposes. This sums up the whole concept of doubly linked list. So start is equals to start of link, and as I already explained, we have to make the right link of temporary node and the left link of start node as null. After it is done, we can just print what is the node deleted. And how do we access the deleted node? We have named it as temp, so we are calling temp of temp arrow mark SSN, and once it is displayed, the same concept of decrementing the count, freeing the temporary variable. We know what is free function. Free is a dynamic memory deallocation function. That means it frees up the space used by this pointer, and we return start as usual in all the functions. So now we have understood insert front and delete front. So let us now go ahead with insert end. We are now with insert end. So again, my repeated ask or recommendation is first understand the concept and then try to write the code. And insert end, what does that mean? We are inserting the new node at the end of the doubly linked list. So we create a temporary node, temp is equals to create. We know why we need cur, because once we are we need to access the last node. We need to start from the starting node and traverse to the last node. Hence we need this variable called cur. We will see in the code here. If start is equals to null, that means if there is an empty DLL or the linked list doesn't even exist. So whatever you create will be the start node. So that is why you are just returning temp. But if that is not the case, if there is already a doubly linked list existing, we first have to come to the last node, because this is insert at end. How do we do the traversal? While current of r link is not equals to null. We know that what is r link? The right arrow. While current of r link is not equals to null, we traverse the doubly linked list, and every time we do the increment. Cur is equals to current of r link. So this is the condition, and this is where we do the shifting forward. Current is equals to current of r link. So this will be current in the first iteration, second iteration this will be current, third iteration the third node will be the current. And before we insert this, we know that the right link of this last node will be null, so this condition will fail, and then it will come out of the while loop. Then we configure the right and left link. So the concept remains the same. Current of r link has to be configured, it has to be made to point to temp, and the left link of temporary has to be made to point to cur or the last node. I hope this image at the left, where I have demonstrated the concepts, and the image on the image on the right, that is the train image, to visualize it better, and then writing the code is actually making a lot of sense and making the understanding really easy. So we have understood what insert end function does. So now you would probably appreciate that even though the program is lengthy, as the case with some other programs, but since we are understanding the concepts, we can easily understand the programs and even write the program easily. Alright, so let us now jump to delete end function. we know what delete end is, deleting at the end or deleting the last node. So when we are deleting the last node, we need two variables or two pointers, that is current and previous. Why do we need previous? After the last node is deleted, we want to make the last but one node, that is the previous node, as the last node. Hence we need two pointers. We know the same condition. If start is equals to null, that means the linked list is empty. And the second condition, if the start of R link is equals to null, that means there is only a single node, we can just print whatever is there in the single node or the start node using the same message, same pattern we followed with delete front as well. We have seen the same with delete front. So there is a pattern in the program. So if you are able to identify the pattern, writing the program is actually easy. So in delete front function, in delete end function, if there is only a single node, we print what is there in the start node and we return null. But if that is not the case, if there is a doubly linked list existing, we have understood what these two parameters mean. So initially previous will be null and current will be the start node. So we will start from here and we will move, we will traverse. So we already know the concept of traversal here, while current of R link is not equals to null. So the last node, so for example, in this you could consider the last but one node is still having a right pointer to the last node, but the last node will obviously have null. So even in this image you could see that the last compartment, it is not linking to anything, that means it is null. That is how we arrive to the last node, while current of R link is not equals to null, previous is equals to current. So initially previous was null, so as the current moves forward, previous will be one step behind or one node behind. That is what we need. Previous is equals to current, current is equals to current of R link. So current will start here and it will move forward. And once we have reached the last node, what we are interested to do is print what is there in the last node, that is print what is there in the current node, because current will now be pointing to the last node. After it is printed, what we need to do is, again, look at the image here, we need to delete or make the left pointer of the last node or the current node as null and the right pointer of previous node as null. So look at the image and then write the code, or then understand the code. Previous of R link is made as null and current of L link is made as null. After we have removed the links, what we are next supposed to do is free the current pointer, because the last will no longer be needed. So we will need to free the space, and after delete operation, obviously we will decrement the count minus minus, and we will return start. So we have understood insert front, delete front, insert end and delete end functions. So in this program, that is program number 8, we are asked to demonstrate how doubly linked list could be used as double-ended queue. In program number 7, we were asked to demonstrate how it could be used as a stack. Again, as I already mentioned, the same pattern is being maintained in both the programs, so it is easier for the readers to understand and possibly write both the programs and execute. Let us understand the display function now. Display function is used to display the contents of the linked list, doubly linked list, and also print the number of nodes in the linked list. So what do we need here? We only need one variable called current or cur, and num1 int num is equals to 1. So num is basically like a serial number. So you see that the first %d is replaced by num, or is taking the place of num, and num is like a serial number. It is not SSN is the you could take SSN as the employee ID, or SSN is actually the social security number, which is the ID given in the United States. But anyway, let us not bother about what the meaning is. So SSN you could consider some identification number of the person, and name we know other data elements already here. Int num is equals to 1. If start is equals to null, that means when is the start be null, there is nothing in the doubly linked list, or doubly linked list is not even present. So we just print no contents to display and we return. If that is not the case, we print this message, the contents of DLL is, and enter the next line. So we start at current, so current at start, while current is not equals to null. So this is I've explained similarly for program number 7 as well. Only in the display function the while condition is slightly different, because in the delete functions, what we are interested to do is we just want to come till the last node and delete it. So the condition is current of R link is not equals to null. But in this case, display function, we don't want to delete any node, we want to print the last node as well. That is why the current, the condition is current is not equals to null. So a slight difference to be noted by the readers. We know how to print the contents of the node printf. You could beautify this using separators like double line and single line respectively, and be careful with how you order the fields in the node. That is, we know that the node has SSN, name, department, designation. You must use the respective type specifiers, %d, %s. So %d is for integers, %s is for the character arrays or the strings, and we know that this salary is again the %d, and phone number is a long integer because phone number is expected to be a 10-digit number, so it is a long integer. So be careful with this type specifiers, and we know how to print the contents of the node by using the arrow operator. So current is the pointer, current pointing to current of salary, current of phone. That is how you would read and understand the print logic. So we know this increment operation. So as we print the first node, we want to make the current move forward. So at the start, current will be here. At the end, current will be at the end of the doubly linked list. So current is equals to current pointing to rlink. So it is moving forward, and this num, as I said, is like a serial number. You will be able to see in the output when we execute it, and so every time we move forward, we increment the value of num. So we have printed the contents of the doubly linked list. We just print one message at the end. Number of employee nodes is, and we are using the global variable count, which is keeping track of the number of nodes in the doubly linked list. So we are now left with only two functions. One is the double-ended queue demonstration, and of course the main function. As we did in the seventh program, first we will understand main function, because demonstration of dq or double-ended queue is just an expansion of one of the choice. So in this main function, the choice number 7, dq demo, this is expanded in a separate function. So let us first understand main function and then come to dq demo. Alright, so probably we don't need this image anymore. We will minimize this and go ahead with the main function. So ch is for choice, I is for the iterative purpose, n is for number of nodes, and we create an infinite while loop, while 1, and we create the menu. It's because it is a menu driven program. Menu, enter your choice for DLL operation. All these are self-explanatory lines. Remember that we are supposed to do insert at both the ends, insert and delete at end, insert and delete at front. So be careful, end means rear or the end of the doubly linked list. The seventh choice is for demonstrating how this DLL could be used as a double-ended queue. So what is a double-ended queue? We know that queue is a last in first out data structure. In other words, if you consider this as a queue, insertion happens at the end and deletion happens at the front. But what is a double-ended queue? As it sounds, in both the ends, that is at the rear end and the front end, both the operations could be done. So I have explained what double-ended queue here itself, insertion and deletion at both ends. So you could insert and delete here, you could insert and delete at the front as well. That is the meaning of double-ended queue. And the last, of course, the last choice will be for exit. After we have printed the menu, we will ask the user to enter the choice, and we will accept the input %d and ch, and we know that we will have to use the switch construct to execute a menu driven program, switch ch. So what is case 1? To create a doubly linked list of employee nodes, printf, enter the number of employees, that will be n, and for each node we are just calling the insert front function. So again, if you have followed the 7th program, I explained that this is a choice left to the user. You could do insert front or insert end. That is not really a best practice, but as I have followed insert front as the default way to insert into the into the doubly linked list, I have done the same with this program as well. For I is equals to 1, I smaller than equals to n, I plus plus, start is equals to insert front. That means you are calling the insert front function. After every case, we are used to we know that we have to break out of the case. In the second choice, we are calling the display function. In the third choice, we are calling insert end function. Remember that insert end function or any or all of these functions, you could see that delete end, insert end, delete front and insert front are returning a pointer type value, that is node. So that is why you should have that in mind and make sure that you are accepting the return value of all these functions, insert end, delete end, insert front and delete front, in this pointer type variable called start. And we know we have created we have declared the start as a global pointer in the program. And what is case number 7? Case number 7 is where we do the double-ended queue demonstration. So we just call this function dqdemo, which we will understand in a bit. And case number 8 is exit. And the default case, if user enters a choice which is none of the above, then we could print this message to enter a valid choice. So we have understood the main function now. We are only left with double-ended queue or DQ demo, and we will next jump on to the execution. So again, I have explained what double-ended queue here means. You could refer this image, insertion and deletion at both the ends. So always, since we are using a DLL for DQ or double-ended queue, the process of adding or insertion and deletion remains the same. That is why you should be familiar with this dotted arrow mark for insertion. So it is that indicates there is insertion happening at the front. This cross line or kind of deletion line indicates that deletion is happening at the front, and the same can be done at the end as well. So that is the meaning of double-ended queue. So if you have understood this, writing this DQ function is nothing but a piece of cake. So you just create another menu here, DQ demo using DLL. We have followed the same convention in program number 7 as well. There it was a stack demo using SLL, but here it is a DQ demo using DLL. And we know what are the queue operations, NQ and DQ, and since double-ended queue allows at both ends, so we have create separate choices for each operation. NQ at front, DQ at front, NQ at rear, DQ at rear, or you could even call it NQ at end also, if that makes let us avoid confusion by just using the same words, NQ at end and DQ at end. And of course the display function is just the same, and we ask for the user to enter the choice, and scanf is where we accept the input, and we use the same switch construct. So just understand that NQ is nothing but insert operation, and we know where it has to be done. So for NQ front we call the insert front function, DQ front we call delete front function, NQ end we call insert end function, DQ end we call delete end function. So this is already done in the main function for the other choices, but for DQ we are doing it in a separate menu here. So for the display function, as usual, we are calling the display function, and the default here, if the user enters a choice which is none of the above, we want the menu to come back to the main menu. So this is the main menu, and you could consider this as a sub menu or menu just for DQ. So default here would be return, and after any of these cases are executed, the control has to return back to the main function. So we are typing return over here. So we have understood the void DQ demo function. So this is not choice 5, so this is choice 7. So these are comments you could add to the program to make the program understandable to yourself as well as to the examiner or anyone reading your code. Since this is a considerably long program having about 220 lines of code, you could add comments wherever necessary. So by now we have understood the whole the whole program. Now let us jump to execution and see if all the tasks are being performed as expected. As usual, we are using the terminal. So this is please keep in mind that this is a Linux based environment, and this is the terminal. This is just the way you would probably see in your laboratories as well. Probably you will see a different colored screen, that will be purple, but at the conceptual level it is all the same, or at the technical level it is all the same. So use the commands that we already know. GCC is the compiler, GCC P8.c. You could also use CC or GCC, doesn't make any difference. Basically it means global compiler. GCC p8.c, p8 is the name of the program. Enter. If there are no errors in the program, you would see that the cursor would just blink in the next line. That is a good sign. If there are any errors, you could come back and make the relevant debugging and go back, save the program and then compile it again. So I hope execution of program is known to all the readers. Then the next command to execute the program is /a.out.out. So if you enter this and click enter, you would enter the execution of the program. So we know that execution of any C program starts with the main function. So we are printing the menu and we are asking for the choice. So let us quickly test out each menu option in the menu, or each choice in the menu, and appreciate the program's output. First we will create a DLL. So first my choice would be 1. So let the number of employees be 3. Here again I am following the same convention we used while we executed the 7th program. So you would if you watch both the videos one after the other, you will understand or you will appreciate that process as well. So SSN, let his SSN be A1, let the name be Ram, department be CS, designation be, so for simplicity I am just calling PR for professor and APR for assistant professor, and salary we could maybe give a salary of 70,000. These are not real numbers anyway, you could just you could put any random numbers. For phone number, again for simplicity reasons I am just entering 4 digits. You could enter the complete phone number if you are interested. So make sure that you are entering the input in the same order as expected. SSN first, name, department, designation, salary and phone number. Click enter. It will wait for the next employee, because we have entered 3 employees. So let the second name be A2, SSN, name be Syed, let him be an IS, let him be an assistant professor with, let's say, 60,000 salary, and his phone number be 8989. Moving on, the third node, the third employee, let his name be John, and in AIML branch let him be a HOD for a change, and let the salary be 90,000, and let the phone number be 7897. Once we click enter, we have inserted 3 nodes or 3 employees into the doubly linked list. So let us now display it. So the choice for display is 2. Click enter. There we go. We have 1, 2, 3 nodes or 3 employees in the doubly linked list. So remember that we are using insert front as the default method to insert. That is why even though you entered 3, so basically how it works is you entered A1 first, that is Ram, and we are inserting A2 at the front. So this is the front, so it is taking the first spot, and then since we entered A3 at the last, A3 is taking the front end, or because we are using insert front operation. I hope all that is understandable and self-explanatory. So we have demonstrated choice 1 and choice 2. Let us now jump to choice 3, where choice 3 means insert at the end. So now if you insert, the expected outcome will be, let's say if you are entering a SSN with A4, A4 will take serial number 4 and it will be displayed after RAM. So let us try and validate that. Let the SSN be A4, and name be Sham, department be IS, and assistant professor APR, and salary be 60,000, and 6787. So click enter. It is inserted. So let us see if it is inserted properly. So how do we do that? By calling by entering the choice as 2. So there, as expected, it was 3 here, and the last node whatever we entered, because we inserted at the end, it is inserted at the end as expected. Now probably next we could do delete at the end. So if we just press 4, the whatever we just entered right now will be deleted. So you will see the message employee node with SSN A4. A4, this Sham's entry is deleted. Next, let us jump to insert at front, choice number 5. You could enter any random data, A5. Let us now have a name like Salim, and department be mechanical, and let him be a professor with salary of about 70,000, and the phone number be 8098. So it is inserted at the front. So we could, so what is the expected output at the moment? We want this A5 to take the front or the first position. So we will display 2 and see that, yes. So this is the beauty of the program. If you understand the program and type the program and or code the program with understanding, you should normally get the expected output. Otherwise, since if you understood the program, going back and debugging the program is not a very difficult challenge. So we have now completed insert front. Let us enter a choice of 6, which does delete front. So this A5, this Salim's entry will be deleted. So let us do that. There we go. Employee node with SSN A5, that is Salim's entry is deleted. So we have completed all the choices. Now we are left with the DQ demo. So the choice would be 7. So when we enter the choice 7, we know that the choice 7 is calling another function called DQ, which has its own submenu. So that submenu is being printed here. It's all just the same. Whatever we did here, we are just calling by different names, because you must understand that the expectation is you have to demonstrate how this doubly linked list could be used as a double-ended queue. So the operation and the code is everything the same. So you would see that the same functions are being called in both the cases. So enter your choice for DQ demo. Let us not spend too much time here. Let us do one NQ and one DQ operation. Let the NQ operation, we could do it at the let's say at the end. So the choice would be 3. Let us enter data like A7, and let his name be Krish, then CS branch, HOD with salary about 90,000, and his phone number be 6789. Alright, so it is entered. Let us display and see if it is doing the same. So there we go. It is, since we did the choice as 3, which is NQ at the end. It is NQ'd at the end, that is insertion operation has been done at the end. Let us now do, let's say, the DQ at the front, just to have some variety in the execution. DQ at the front. So DQ at the front is the first entry, that is SSN with A3 is deleted. So we have successfully demonstrated how this doubly linked list could be used as a double-ended queue. So we know that the default entry, default case here would be to going back to the main function. So let us enter some random number 9. So if I enter 9, it is taking me back to the main menu. So this was the sub menu. So here we have understood all the all the functions, and we have executed all of them, and we have demonstrated the correctness of the program. So we are now only left with entering the choice of 8 and gracefully exiting the execution and the program itself. So there we go. We have in this video we have convincingly understood the concept of doubly linked list with the theory and the train image as well, and we have understood each function and the execution as well. That was all in this video. Thank you.